Good morning. This is a quick audio check.
Good morning.
Saral, thank you very much.
Good morning, dear participants. It is my pleasure to be one of the moderators for day one of ATAL FDP on smart cities, concepts, strategies, opportunities, and challenges. I am Mrinal, Assistant Professor, Department of Civil Engineering, and on behalf of NMIT, would like to extend a very warm welcome to all of you. So we appreciate you taking time off your busy schedules and virtually joining us today. Now, with the program, request all the participants to yourselves and to keep your videos off throughout the session. And in case of any queries, please to post your queries in the chat box will be shared at the end of the session. We are pleased Sri BSc Rao and practicing civil engineer with us today. Sir, with the session, since the number of participants are less, there's a small video, sir. Can we play the video, sir, or would you like to start with the session?
No, it's up to you. If you want to wait for another, only thing is, as long as you don't cut down my length of talk because of this, which is what usually happens in conferences.
Of 3 minutes.
Oh, yeah, go ahead, please do.
Thank you. Once again, I would like to welcome. Once again, I would like to welcome Dr. B.S.C. Rao, sir, for this session. We did not want the participants to miss your session, so that's why we played this video, sir, as a buffer time. So hope you don't mind. Okay. And by not wasting much of a time, now I would like to hand over the session to you, sir. Over to you. So
Okay,
could you
thank you.
please share your
I'll do that.
presentation?
Thank you very much. In fact, that video was a very welcome addition because it saves me a lot of effort in trying to explain some of those things. As it is, my talk is going to be fairly long and it's not possible to cover everything in one talk. And so this is a very good introduction. Thank you very much. I'll now share my screen. Please let
Yes.
me know if you can see the presentation.
Sure.
Can you see that?
Yes, sir. Yes, sir. It's
Can you see
visible.
my presentation?
Yes, sir. The presentation is visible.
Okay.
Uh,
Okay, I made it full screen now.
yes, sir. It's visible.
Okay, and my audio is also good.
Yes, sir. It's all clear.
Okay, thank you. Thank you very
Thank you,
much.
sir.
I'll now start my presentation. I'll try to finish it within the allotted time or maybe less because we're already running quite late. But it's a fairly long presentation and consists of two parts. I had prepared for 2 hours as Dr. Bharti had told me earlier. I'll see how much I can try to reduce it in order to fit the available time. Okay, first of all, I'd like to once again thank Dr. Bharti Ganesh and NMIT for inviting me to give this keynote address. I hope at the end of this address, you would have got some idea of what smart cities are and where we are going as far as our smart cities mission is concerned. What is this? Annotate shared content. What is this? Ankit Verma. Is it for me to do it or? Okay, now I'll.
Sir,
I don't know. Something is it's stuck for some reason.
can you help, sir?
No, I don't know. Something has gone wrong here. What is this one? Okay. Okay. Yeah. Okay. So I'd like to start with a short disclaimer. I am basically a urban mass rapid transit and transportation professional. I'm not a specialist either in smart cities or information technology. And whatever you see in this presentation is what I have obtained from the public domain and arranged it according to my understanding. So if there are any errors and omissions which you find, please do forgive me and please do let me know subsequently. The structure of the presentation will be in two parts. One is smart cities, what are they, where basically I will try to where I'll try to present the fundamental requirements for smart cities. And the second part of it will be India's smart cities mission and where we are going on that. Okay, this is basically the structure of the presentation of the first part, growth of cities and urbanization and so on. Anyway, you can read it yourself. There's not much that I can do by reading it. Basically, this will talk about technology. I mean, ultimately, smart cities, the whole smart city concept depends on having a very strong technological base. And so this part of the presentation will concentrate essentially on the technological basis that is required for smart cities to be successful. Okay. Smart cities, the concept of smart cities started with the realization that cities are growing very, very rapidly, and all over the place, urban populations are decreasing very greatly. In fact, now what is happening is there's a reverse trend, and populations will actually start declining in the rural areas, and they are all shifting to cities, and therefore there are massive pressures on urban and financial and infrastructural requirements in cities. So which results in conflicts, inefficiencies, and in city management delays and so on. Look at these statistics. World population was 7.8 billion in 2020. It's going to go to 9.74, and by 2050, 68.6% or 6.68 billion people will be living in cities. And most of this will happen in Asia and Africa, with 37% from India and China, as I mentioned before. So this is some statistics that I've got. And what you see here is by 2030, the number of smart city, number of cities with populations of 10 million, what they call the 10 million plus population cities, are 41, are likely to be 41. Tokyo will be the world's largest with 37 million, followed by Delhi at 36 million. Cities consume 75% of the world energy and produce 80% of the world's CO2. Modern cities pose the greatest environmental challenge, which is what now the sustainable development goals, which are being pursued all over the world, are trying to reduce. The other thing is that as the population of the city doubles, crime rates also increase by about 15%. Urban population growth in India very quickly. We have 2014, we had 410 million urban population of a total Indian population of 1.28 crores. And this will go up to 854 million by 2050. And you find a very exponential rate of growth in urban population in India. So these growing urban populations, along with constrained financial and natural resources, are shaping requirements for evolution of smarter and safer and greener cities. Governments are under tremendous pressure to manage very scarce financial resources and invest in sustainable infrastructure, establish robust communication and information systems, and deliver quality services to citizens and people. So, what people believe is that ultimately smart cities, I put that in quotes, because this question of smart, like Dr. Gopalakrishnan was saying, it's another sort of buzzword that's going around, a kind of jargon that has come up. So, under the moniker of smart, anything can be passed off. I think we need to understand what exactly smart means here. Anyway, smart cities are supposedly the answer to meet these huge challenges of urban life. Essentially, what they intend is that you cut out quite a lot of the physical and manual requirements for conducting life and converting it to electronic and digital systems. So these are very complex projects and require expertise in many different fields to succeed, including necessary funding, urban planning, architecture, transport, energy, technology, and communications. Ultimately, the whole of the smart city program depends on communications and technology, as we'll see a little later. They are necessarily joint venture projects. No government has the total finances and resources required to undertake these massively expensive projects. And therefore, private partnerships are also essential. And this requires constructive engagement between public and private sectors in financing citizen engagement and technology. The government alone cannot do it all. So what really are smart cities? There are many definitions, and depending on who you talk to, the definition will slightly differ. But generally, it is understood to mean enhancing the quality and performance of urban services, reducing costs and resource consumption, and engage more effectively and actively with its citizens. Ultimately, it is meant to help the average citizen lead a better life. 4 factors contribute to the definition of smart city. Application of electronic and digital technologies, which is the backbone. Use of ICTS, that is information and communication technology systems, to transform life and working environments. Embedding of ICTS in government systems and practices that bring ICTS and people together. So we are depending more and more on technology and especially the internet in order to help our lives become much better and more satisfying. There are many, many other aspects of smart cities which I am not going to go into here because this requires, you can have a 1 month program on this and still not be able to complete it. There are 8 key aspects that define a smart city: smart governance, smart energy, smart building, mobility, infrastructure, technology, healthcare, and smart citizens. So again, the word smart is used in all these things because ultimately it is delivered on the basis of technology. Okay, we have the 9 anchors of smart cities: smart mobility, buildings, smart utilities, smart waste, smart education, smart health, smart stakeholders, and smart governance. all of which are interrelated, and everything has got a connection with everything else, and they are all connected through information and communication technology, which is ICT. So the whole fundamental basis for the smart city system is information and communication technology. It's based on technology, and that will be the essential focus of what I'm going to be talking today. This will not be like other smart city lectures where you will talk about the various pillars of smart cities and so on. I'm not going to talk individually, for example, of smart mobility, building smart utilities, and so on and so forth. I'll be talking more about information and communication technology because that is not what is often addressed when smart cities are discussed. Okay, now these are just to give you, this is just a representative slide to show you what each of these terms mean. Smart economies, entrepreneurship, innovation, local and global competitiveness, productivity, networking, interconnections, and so on. In environment, we have green buildings, green energy, green urban planning, waste management, pollution control, and so on. Smart government is enabling supply and demand side policy, transparency and right to information, open data, e-governance, and stakeholders participation. There are a number of components for each of these things again. Smart living, of course, is health, safety, and security and contentment of the citizen. Smart mobility, this is a big subject by itself. Mixed modal transport, intelligent transport systems, integrated transport systems, smart vehicles, priorities and non-motorized vehicular systems, and so on. And smart people is basically to give greater tools to people so that they can enrich their lives and become more productive in whatever they do. So we have modern education, creativity, and inclusive society so that everybody has a chance to take part in the program of the whole city and life. And of course, as again, all of this is fundamentally underlain by ICT, which is information communication technology. What is information communication technology? It's okay, this you have seen. It refers to any device or system that allows the storage, retrieval, manipulation, transmission, and receipt of digital information. It also means merging of audiovisual, telephone, and computer networks through a common cabling system, which includes telecommunications, broadcast media, intelligent management systems, audiovisual processing and transmission, network-based control, and monitoring functions. And it stresses the role of unified communications and integration with telecommunications, that is telephone and wireless signals with computers. So it's a marriage between the communication system, the internet, and the computers, with the necessary enterprise software, middleware, storage, and audiovisual systems, which enable users to access, store, transmit, and manipulate information. So it's a question of the internet connecting the world and the method of processing the tremendous amount of data that is going to be produced, as you will see later on. Okay, it consists of 4 parts. One is information. Next, you have communication, technology, and systems. Information is, there are many types of information. It can be discrete, it can be distributed, spatially, geographically, demographically, and there are various types of various types of information in different formats and different sources. It can be digital or analog. It can be static, dynamic, streaming, intermittent, and so on. Then we have audiovisual communications, video conferencing, social media, communication networks, digital radio, TV, GIS, GPS, mobile phones, internet, broadband, cloud computing, and now there's a new thing called edge computing, which has come up. And then, of course, we have the internet itself overall. Technology is basically the hardware, transmitting, receiving, recording, and storage devices, computers, laptops, scanners, printers, RFID chips, sensors, actuators, cameras, TVs, and so on and so forth. And then we have what is known as the Internet of Things. And lastly, we have systems which basically combine all of these 3 systems into a manageable network. So we have systems to manage IC and T with hardware, software, data, and people. It's a sort of an interfacing system that we have. So here you have the software, the algorithms, and so on and so forth. You have the inventory control system, management, traffic management systems, and various types of control systems. So this constitutes the heart of what is known as ICT. Now, in this talk, I'll briefly touch upon RFID chips and sensors and actuators. We'll talk about Internet of Things, and we'll talk about cloud computing very briefly. Okay, RFID sensors. RFIDs are radio frequency identification devices, which we are all very familiar with, but which may not be really aware of. It is basically a transponder, that is a transmitter receiver, which receives a radio signal, and in response, it sends out a radio signal which identifies it. The identification of signal can carry information of many types depending on necessity and use. It can be extremely small in size, and it can be printed or etched. This is a tremendous revolution that has taken place, and as you can see in the figure on the right side, in a very, very small area of about 1.5 millimeters by 1.5 millimeters, all of these things can be integrated into it. And basically what you have here, this series of wires that you see around is the antenna, and you have the IC chip, which can be programmable, and you have a substrate, and you can also have integrated into this a very, very tiny battery, or it can be even solar powered if you require it. So the RFID technology has tremendously improved, and you will see later on how this, when it is combined with sensors, become a very, very powerful tool in the ICT world. So what it basically does is that you have a tag or a transponder which receives a signal from let us say an antenna here, and in response it sends back a signal which is then read and then ultimately sent to the computer for you to be able to see it, or maybe on a smartphone. So RFID types, there are many types. There are active, passive, semi-active. Active is which has its own power source, and therefore it has a much longer reach. Passive is where it draws power from the reader, as you saw in this picture on the right side. And semi-active is for sensing and storing information, but not for communication. RFIDs are principally used for tracking, counting, identification of objects or things, and can be combined with sensors for measurements. So these are usually used where you need to count things or people, or any kind of, like for example, in inventory, storage facilities, access control, hospitals, libraries, offices, and so on. RFID systems can individually track objects at over 1,000 tags per second. So it can be extremely fast. So in, for example, supply chain systems, it can play a very, very major role in identifying and recording the number of objects that are going and the type of objects that are passing by. Now, all these we are very, very familiar with. This is a price tag, and behind that you have the RFID chip, and this is the antenna that you see here. And likewise, in your Visa card, you have a small chip which also has an RFID, which is how your contactless smart cards and debit cards work. And then, of course, we are all now familiar with the fast tag system that we have in India. This smart tag, the fast tag which you stick onto your car, has an RFID, and as you pass through the toll gate, it draws power from the toll gate and then sends back information about your car. So the chip contains all the information about your car, the owner, the driver, the RC book, the registration, and the insurance paid, and the whole lot. And all of this is done automatically without your being even aware of it, and at the speed of light, because it's all electronic. The other is application of RFID is in body implants. In fact, today we have got very, very tiny RFIDs which can be put into small capsules that can be injected into your body, or it can be stuck onto your body, as you see on the right side, and it can provide information about your health. It can be information about your internal organs. It can have a it can be combined with a tiny camera to send real-time photographs of what is happening inside your body. And in 1943, Jewish citizens were tracked by the Nazis by tattoos on their arms. Today, all that you need to do is put an RFID chip into a person, and you know all about him and where everything about him, including where he is going, what he is doing at any point of time. In fact, there was a statement that in the US, they wanted to, under Obamacare, they wanted to put RFID chips injected into people, whoever came for a health checkup, until it became a major controversy and a scandal, and then I think it was stopped. Now, sensors are a different category of device, and they basically are measurers. They measure different kinds of things. And as you can see here, there's a whole range of sensors that you can have, which can be used. Now, these can be combined with RFIDs to actually measure and also measure the particular properties, in addition to, of course, getting the number. And if you have GIS and GPS put into it, you also have location. So there are a number of different types of sensors. In fact, hundreds of sensors are available today. So this just gives you, and they can be very tiny. They can be very, very tiny also. So this is just to give you a representative idea of what these sensors are. Now, one of the latest or rather newest developments in sensors and RFID is the what you call the smart dust, which is actually very, very scary. There are many tiny micro electromechanical systems, what are known as MEMS, which comprise of sensors, robots, and other devices that can detect, for example, light, temperature, vibration, magnetism, or chemicals. And they are usually operated on a computer network wirelessly and distributed over some area to perform tasks, usually sensing through RFID systems. Now, why this is scary is because they are extremely tiny. The smallest sensor is 0.15 by 0.15 millimeter. That is much smaller than a grain of sugar. Now, imagine that if you are able to, join this with an RFID chip, and you have a sensor and an RFID chip, and along with that, you also have, for example, a system of delivering a certain kind of product, then what happens is that these are extremely light and extremely small, and so hundreds of millions of them can be produced, and all that you need to do is spray this over an area. Say, for example, of course, they have got many different uses for that. You have military applications, you have agricultural applications, you have pollution control, environmental applications, and so on. So, for example, if you've got a highly polluted area, you can spray these hundreds of millions of sensors, and it will give you real-time. Every one of them will give you real-time information. For example, if you're programming it to measure, say, for example, toxic gases in the air, it will go on sending real-time, 24/7, the information contained in the atmosphere. And imagine this data coming from millions of these things to a centralized computer system, and you can imagine the amount of humongous data that you get. Of course, what it does is that while you get all this data, you can also get a much, much better and far more detailed picture of what is actually happening. Now, similarly, you can put these sensors over a forest fire, and you can get exactly how far the fire has spread. You can put it in agriculture, and you can find out what the ambient moisture content is, what is the ambient weather conditions are, and so on and so forth. So it can measure temperature, humidity, air pollution, light, radiation, chemicals, magnetism, vibrations. So it has got tremendous uses. The only danger is that you can disperse it very easily, but you cannot get rid of it very easily, because they are spread like dust all over the place, and it's impossible for you to retrieve all of them. So this is where the security aspect of it comes in. And of course, as you can imagine, this will have tremendous utility in military systems. Now, as it is in our world, we are already we are already in a very, very electronic world. And today's cars are unlike the cars of 40 or 50 years ago. In fact, I remember that as a child, my father and I, we used to dismantle a whole car and then dismantle a whole engine and put it back together in our garage. Today, I can't even imagine opening the lid of the car, because there is so much electronics and it's so complicated that it's impossible to repair it. It's only replace them. So today's cars have 60 to 100 sensors of various kinds, and the number is increasing, and you have an onboard computer and so on. And now we are talking about driverless cars. We are talking about self-driving cars and so on and so forth. So it's becoming more and more automated and less manual. And that is the way we are going on in the world. Now, all this gets integrated into the overall smart city, concept that we are looking at. What I'm showing you is basically are the technological foundations required for smart cities, and which drive the entire smart city program. Now, this man is a very interesting person. He is the most connected man on earth. You can call him a bionic man. Chris Dancy has got 700 sensors implanted into himself to capture every single detail of his existence, including his body health, body chemistry, and everything else that you can think of. And he monitors it constantly. Now, I don't know why anybody would like to get 24 by 7 millisecond details about what is happening in the body and so on and so forth. But this he did it as an I mean, he did it to probably showcase what can be done. And this is supposed to be, I mean, he became quite famous because of his being connected through 700 sensors in his body. The city of Santander in Spain is also a very, very connected city, and it has got 20,000. This was quite dated. This was taken in about 2014, but it has got 20,000 fixed and mobile sensors. Similarly, you have cities in Korea, and you have cities, I mean, for example, Singapore, which have also deployed thousands of sensors all over the city. And China has gone way ahead in putting security cameras and various kinds of detective devices and sensors all over the cities in, for example, Shanghai and Beijing and so on and so forth. In fact, we were quite surprised when we visited China about 5 years ago about the number of surveillance systems that they have got. But that is way cities are evolving. Now, this chart basically shows you how these sensors can be used for so many different types of applications. This is a very famous graphic that you find. You can get it easily on the web. But it gives you, I mean, out of 50, they have listed 22. And it just shows you that all of these are again managed by sensors and the ICT system, because they are all connected. They are all connected to central servers, and there is somebody watching this all the time. I mean, you can have a number of different servers, you can have a number of different management people, but ultimately, everything that is going on in the city can be monitored in real time through the use of these sensors. Okay, then we come to actuators. Actuators are again very, very tiny mechanical devices, electrical and mechanical devices, which are used to operate stuff. For example, here, which linearly moves, rotates any object in response to a given signal impulse. Hello? Ms. Shweta, you'll have to mute. It can be operated pneumatically, electrically, or hydraulically. Typical example is the autofocus in your cameras, in the old cameras that we used to have, where the lens goes forward and backward. Or it can also be made to, for example, you can, through your smartphone, you can lower and raise the blinds on your what do you call, windows. Or you've got programmable beds, you've got programmable heaters. So through the smartphone, you can operate all of them. And you can, for example, ask your robotic vacuum cleaner to start moving. So you can have switches which you can operate. Actuators can actually operate switches through your smartphone. So these are all the kind of applications that you have. You can run the fire alarm, you can start the lawn sprinkler, and so on and so forth. Then we come to cloud computing. Cloud computing is again basically the internet cloud, what we call the internet cloud. So it's got a new word. It refers to servers that are accessed and shared over the internet and the software and database that run these servers. Basically, this is a shared service system. You have got hundreds of computers, thousands of computers, hundreds of servers all over the world. So what they are trying to do is to start using all these servers and computing power that you have to produce a centralized, processing service, so that you don't have to necessarily own those those computing facilities yourself. All that you need to do is access the internet, and you can make use of the services. You can make use of the programs. You can make use of the computing power in a computer located somewhere else. So that is what we call the cloud, the internet cloud, and where various devices like laptops, servers, desktops, tablets, phones, etc., are connected through the internet, through all these various shared service providers that we have. Cloud servers are located in data centers all over the world, and users and companies don't have to manage their own physical servers themselves or run software applications on their own machines. We are already familiar with this, as you will see later on. It uses the concept of utility computing that gives on-demand shared services to the end users. For example, today, things like AutoCAD, things like Office 365, Salesforce, these are all things where you don't have to necessarily purchase the entire program, or you only rent, or you only pay for those services that you actually use. So examples are, for example, the Amazon cloud, which you are all very well. Amazon user has got the largest cloud share. Then the Google cloud, where we share where we store all our photographs and media and so on and so forth. The Apple iCloud, Office 365, Salesforce. These are all cloud services. In fact, the number of cloud services are a very, very large number. So Amazon leads the market with a $100 billion cloud share, and it's about 33%. So all of these basically provide services for you to save you the cost of owning hardware and software, and you can have minimal hardware and yet be able to access the best software anywhere in the world. And that is what cloud services enable you to do. Now, this has got a great use in the management of smart cities. So this is a representative picture of how you find hundreds of thousands of users and a few hundreds of servers, and yet these few hundred servers can service millions of users. This is a very representative picture, that's all. Then we come to the Internet of Things, or the Internet of Everything as it is also known. The Internet of Things is a globally interconnected network of computers which can communicate with each other through a common communication protocol, the TCP/IP, to exchange data and information. A thing, when you say Internet of Things, a thing is any uniquely addressable intelligent object which can be connected to the Internet and communicate with other similar things or a computer. So what it means is a thing can be anything. I mean, it can be a refrigerator, it can be a light switch, it can be your car, it can be your robotic vacuum cleaner, it can be anything. It can even be your air conditioner or your window blinds and so on and so forth. Anything that can have a chip and which you can communicate with wirelessly, it becomes a thing. So each of these must have its own independent, unique address, so that you are able to connect directly with that particular object and nothing else. So the Internet of Things can be defined as a network of uniquely addressable intelligent objects. Intelligent here basically means something that can receive your signals and respond back. It is not intelligent in the sense of human intelligence, but it is just that it is able to receive and respond. That can be connected to the Internet and can communicate with other similar things or a computer through a common communication protocol to exchange information and data. Such things do not turn into computers. They can be very passive, but they can incorporate tiny computers to do many smart tasks and are programmable or can be controlled. When they do so, they are called smart or intelligent. For example, you may have a refrigerator which has got a programmable function which already is available today. So sitting in your office as you leave for home, you can send a instruction to the computer to keep your beer ready, for example, at a particular temperature. Or you can ask the oven to start off and keep your dish ready and nicely cooked by the time you come home. Or you can ask your air conditioner to start off 10 minutes before you come so that the room is cool before you even reach home. So these are all things which you can address through a smartphone or through a computer wirelessly through the Internet, and the thing then responds in response to your instructions. So that is what is meant by smart or intelligent. So the word smart this is really the meaning of the word smart, which basically means that these are all things that can receive signals and respond back. Okay, we have all these various things as you see here. These are all the things, and they are all sensors with reporting data. They are all connected to the web. They have got metadata that their individual data is also registered. They are all readable remotely, and they can be controlled remotely, and all are connected via the Internet cloud. So all of these can be accessed from anywhere by anybody who, of course, who has got permission, and you can read and what do you call interact with all of these remotely through the internet web, the internet cloud. So the Internet of Things connects every industry, whether it is home, industrial, automotive, agriculture, it can be military, it can be environmental, all of this. All of these are connected, interconnected. So how many IoT devices are installed worldwide becomes a question that you would be interested to know. In 2018, there were 7 billion. In 2019, it went to 26.6 billion. And 127 IoT devices are getting connected to the web every second. 2020, they had estimated 31 billion. By 2021, it's 35 billion. I'm told it's now 37.5 billion. By 2025, it is 75 billion IoT devices across the world. And in 2030, 125 billion IoT devices. This is a tremendously large number, and it's exponentially increasing as more and more devices get connected to the internet. And now each of these will need to have a unique ID. That means every one of them must have an individual address which can be accessed, so that when you send a signal, it goes to a specific thing in the world, and it's not confused with something else. So if you've got one refrigerator, if you've got two refrigerators, they will have two separate IDs, in much the same way that each computer has got a separate ID. You know, the usual four component ID that we have. Now, each one of these would be generating data, most of which will be doing so on real-time continuous basis. Imagine the humongous amount of data that will be generated. This is called big data. And again, that's a buzzword, and it's also a new jargon. And the analysis and parsing of big data is now a new field, new and a very, very hot and expanding field called big data analytics. In fact, that's a very, very hot field. If you go to Google and find out, you will see how rich it has become and how vast it has become. It is one of the hottest new fields in information technology, which is something that the students will be particularly interested in knowing. Of course, we are beyond. We are now too old for all this. Even trying to understand that becomes a problem for me. But for the young people, I think it's going to be very, very exciting. And this is the kind of exponential growth that you're getting. And imagine all of these devices generating data all the time. So it's hard to find a product today that doesn't have some kind of connectivity, whether they be home appliances, medical equipment, sports equipment. You already have Fitbit, which you stick on your arm, and it records everything that you do during the day, the number of steps you've taken, number of calories you've burnt, and so on and so forth. In automobiles, defense hardware, of course, surveillance equipment, and so on. Anything that can accommodate a chip can become a thing. The financial impact of IoT by integrating all these is predicted to grow at about 2.4 trillion by 2027, and will have dramatic impact on everything from city planning, first responders, military, health, and dozens of other environments. 5G, which is now being talked about everywhere, is an essential requirement for the new ICT world. And artificial intelligence and machine learning are becoming increasingly critical requirements for IoT to decode and parse meaning to make sense of the mountains of data, which is now called big data analytics. And this that will be, and to understand what this data is, you need algorithms that will allow you to discern patterns, trends, and gain valuable insights into the dynamics of the marketplace. So big data analytics is becoming a very big issue, and 5G networks are going to be an essential component of information and communication technology, especially in the context of the number of programmable and intelligent devices that are coming into play every day, every second, in fact. And now, as a what do you call, an extension of the cloud system, the internet cloud, we now have edge computing. I'm not going to get into that. That's a huge field by itself, where you, instead of having servers at a distant place and taking care of your needs, they are now moving this to the edge of the cloud. Basically, the edge of the cloud, much closer to where you are, and maybe even on your own system itself. So the services are not provided in some distant computer, but the services are brought very, very close to you, or maybe into you, or into your system. So that is the new edge computing which is being brought in. This is mainly in order to reduce the what you call the time delay that occurs when you input data and for the output data to come back if the servers are at a very great distance. So in order to reduce what they call the latency that is inherent in such processes, they are now talking about bringing all these services more or less to your doorstep. That is edge computing. So IoT is poised to open the door for IoT vendors, silicon foundries, software designers to develop products for literally tens of billions of connected devices over the next few years. But how can all of these devices have individual and unique addresses to be individually identifiable? We now are very familiar with this 172.16, this 4-component address system that we have now. Now this is not sufficient anymore. As it is, these IPv4 addresses are already exhausted. It is something like your 9-digit mobile number. If you run out of numbers, then you have to go for 10 digits, as it happened in the case, for example, of our PIN code system. So earlier, if you in the old days, we just had 2 digits or 4 digits, and then it went up to 6 digits now. And if the number of places increase, then you may have to go to 7 digits. So in the same fashion, the 4-component system that we have now, IPv4, has been exhausted, and you cannot have more addresses allocated. So now they are coming up with IPv6, and it gives you, look at the number here, it gives you 2 to the power of 128 addresses, which is virtually unimaginable. What does it mean? To give you some idea of what that means, if you have the IPv6 system, you can have 52,000 trillion addresses per person on Earth, or 100 addresses for every atom on the surface of the Earth. I mean, these are all, numbers that have been generated by somebody. You can take it or leave it, but it gives you a kind of feeling for how big this number is. There are currently 5 types of IoT applications: consumer IoT, which is light fixtures, security systems, home appliances, CCTV cameras, voice assistants for elderly, and so on and so forth. Basically, the home sector. Then we have commercial IoT, which is healthcare, transport systems, intelligent transport systems, smart base makers, smart hospitals, pollution monitoring systems, and so on. It also includes your smart parking and other things. Then we have industrial Internet of Things, where you have digital control systems, manufacturing processes, smart agriculture, robotics, industrial big data, and so on and so forth. And then you have infrastructure IoT, which is wastewater management, infrastructure sectors, power management, intelligent transport systems, vehicle to vehicle, what they call the connected vehicle technology, communications, smart signaling, telecommunications, ship to shore, ship to satellite, satellite to satellite, satellite to ground, and so on and so forth. All of these basically infrastructure. And lastly, of course, military applications, which are quite hush-hush and you really don't know much about it. But if you go to Google, you'll find some very, very interesting information that's available on the kind of applications that you have for military objects, and military things, again, to use the word. So you have robots for surveillance, you have human wearable biometrics, you have drones, and so on and so forth, all of which are military applications. Now, this is of course, you'll find a number of different charts of this kind. If you go to the internet, there are dozens of different types of charts which show you how the smart city can use all these IoT technologies and uniquely addressable things in management of smart cities. So this is just to give you an idea of the different kinds of applications for smart technology. Now here, very briefly, we'll go through what this has. We have IoT in the home, where you have video cameras, surveillance, humidity sensors. This is just a representative selection. Sound detection, environment and conditioning, health and safety, cleanliness, for example, at home, home environment, and so on and so forth. So that is IoT in building and house applications. So here we are familiar with all of these. We have the Google, the very well-known Alexa that we have, which we use. Then we have smart watches, we have smart locks, we have smart refrigerators, we have smart beds, we have got even smart toilets today. So all of these are programmable, they're all communicable, and this is something that is now becoming more and more common in homes, more so when you go abroad. So basically what happens is that your life is no longer private. You've got all these things monitoring you without your being aware of it, and you don't know where this information is being sent. And it raises some very, very serious security concerns. Okay, IOP based healthcare is another where you can have a person completely wired up and you can put different sensors into him, and a person sitting in a hospital 500 miles away can then treat you, as we already have. Telemedicine is already here. So we have, for example, Dr. Devi Shetty sitting in Bangalore treating a person with cardiac problems in Assam. So that has become a reality. So IoT-based healthcare is going to explode. With the number of different types of sensors that are coming up, this field is going to really explode. But it will also make life much easier. Can also make life much more complicated, because you're no longer you have become an object for the scrutiny of some other person somewhere else. Then we have IoT in agriculture. These are all very, very useful applications of Internet of Things and sensors and so on and so forth. And it greatly helps in increasing productivity, in increasing efficiency, in increasing in having more sustainable systems where you use less resources and get more productivity and so on and so forth. So here, for example, in agriculture, you can have climate conditions which are checked up, soil conditions. Precision farming, you can have farms that are dedicated only to certain crops in certain areas, and you can control the atmosphere for that area individually without having to worry about weather conditions and so on and so forth. We have smart greenhouses. We have data analytics to tell you how much is growing, what is growing, where it is growing, how well it is growing, and so on and so forth. Then we have livestock inventory, livestock health monitoring, logistics, and how many people, how many animals you've got, what is their health, and so on and so forth. And this is an application to show you how putting a simple strap on a cow, and on all animals for that matter, you can get complete health information as well as location and numbers of all the cattle and all the livestock that you have. In fact, today we have got it become a common practice to have a chip implanted into your pet dog, so that you are all the time aware of where your dog is, and you're also aware of what its health conditions are. I'm sure quite a lot of you know about this, especially for pet dogs. Then we have IoT in governance. Again, these are all only representative, labels that you've got here. The number is very, very much larger, but it gives you the kind of picture of what IoT can do for you in governance. So you have smart cities, city planning and control, defense, creating jobs, and so on and so forth. E-governance becomes a major part of this exercise. Then in law enforcement, you have traffic signals, crime control, variables for law enforcers, unarmed vehicles for the higher surveillance, court systems, and so on. So for example, here, you have iris recognition for security, which you have seen when you go abroad, for example. You no longer need to even show your fingerprint or anything like that. As you're passing through, or nowadays, of course, you've got iris security systems where you just look at a lens and your entire details are noted. Especially if you go to Abu Dhabi or Dubai and so on, that is the first thing that you get done there. Then, of course, CCTV cameras are becoming universal all over the place. And you see the number of electronic items on this police officer, and it's going to increase. As it is, he is already a very wired person, and he also knows everything about you. So, in fact, today's systems are such that if you are traveling in your car and you pass by a toll gate, every detail of your car is automatically known. And if you are not paid your insurance, or you are not paid your traffic challans for a long time, that automatically gets displayed. So law enforcement uses IoT very, very greatly today. Then we have IoT in energy management, the smart grid. I think Dr. Gopal Krishnan also talked about it very briefly, where the entire grid system is managed centrally, and it can be operated centrally, and you don't need to, and you get real-time information about how the grid is performing, whether there are any problems anywhere, and immediately you know where it is happening and what kind of problem you have got, so that you have got automatic diagnostics and so on and so forth, so that the people concerned on the field can immediately attend to it very quickly who are nearest to the particular problem. It can also help you in exercising greater control over power infrastructure resources and also usage and revenue, therefore. So this is smart grid in energy management. Then we have intelligent transport systems. This is, of course, a massively interesting subject, which can have a separate 5-day program on just intelligent transport systems. When I first got into it a few years ago, I was fascinated by the number of things that are possible in the management of traffic and transport systems. In fact, today you have driverless cars, you have driverless trains, and so on and so forth, all of which depend, and you have automatic anti-collision systems. All of these come under ITS, which is Intelligent Transport Systems. And again, the different technologies that are available there are manifold. And you have artificial intelligence and neural network systems, which are, I mean, these are all words which have come up in use in the last 20 years or so. But they are now dominating the entire conversation in technology. And it is because of that that all of these things are possible. And all of these ultimately will contribute towards making a city much smarter, in the sense that they can be centrally controlled. You can have information coming in real time. You can have better control over your city resources. Okay, that is just to give you sort of an overall idea. There are, of course, a number of different other applications similar to this, which I'm not getting into. This is just to give you a sort of a overview of the kind of technological applications that ICT enables you to do. But this comes with several serious risks. Again, I don't. This presentation is actually a part on just ICT alone. I had a 2-hour presentation where I talked much more about each of these things, and especially about how these things can create very, very serious difficulties for people, in addition to their being extremely useful also. So we have a flip side to the digital world, which is risks, vulnerabilities, and dangers. We already know about quite a lot of these things. Every day we read about people getting cheated on the internet, on the on the loan apps and so on, which is now dominating the news, where people apply for a loan and then they get caught in a electronic web and ultimately lose lakhs of rupees. That is already happening. We have got cases of people entering locked houses because their house is digital, and once you know the password, the whole house is open to you. So these are all very real dangers which have already come up. Now, some time back, these were the kind of 70% of the devices used unencrypted. That means without passwords, network services. You should never latch on to a network which is not encrypted. So when you have the URL address, you have HTTP : and then /, which is an unencrypted one. It's not a safe one. But if on the other hand you have HTTPS, that is secure, then you can be sure. So all bank transactions are on HTTPS networks only. 90% of the devices contain at least one item of personal information, and if you access any one of these intelligent devices, you can access all the others because they are all interconnected. 70% of the devices along the cloud failed to prevent attacks. 80% were insecure or failed to require passwords. 60% had serious security issues and were vulnerable to attack. So theoretically, it's not theoretically, practically also, for example, a criminal who wants to take over a city, and all that he needs to do is latch on to the signal control system of the city traffic. And all that he needs to do is enter one command, and the entire traffic system of the city or an area can go into total chaos, because the traffic lights won't start behaving as they are programmed, but according to what this hacker has done. So hacking has become a very, very major issue, as we all know. Now, these are just some of the lists of vulnerabilities and the dangers that we have. These are the top 10 vulnerabilities of Internet of Things: insecure web, insecure cloud, insecure mobile, insecure network, software, poor physical security. People don't even take care to lock their houses. or to secure their electronic equipment, insufficient authorization or authentication, insufficient security configurability. That is why you need to have strong passwords. So weak passwords are something very easy to guess. Lack of transport encryption, privacy concerns. Privacy is becoming a major issue. And in the house, you will find that this was again a few years ago. There are 5 IoT devices enabled. This is of course in the US. 89% want access of their personal personal information to be controlled. 65% feel their devices will be hacked. 93% view hacking as burglary. So it raises ethical issues. It raises legal and criminal issues, and a lot of problems for both the legal fraternity as well as people, and there are ethics that also come into picture. So Internet of Things security issues require a very major rethink on risk management. So the risks and dangers are very real, and they only increase with time as technology gets more sophisticated. But the criminals are even more intelligent, they're even better equipped. What can happen? Quite a lot of these things we are already familiar with: identity theft, hacking, terrorism, loss of privacy, control with somebody else, insecure networks. For example, the Google Street View is a major invasion of privacy, and a lot of people don't like it. Very expensive, denial of service, Big Brother, and so on and so forth. So the question is, who owns the IoT and who is responsible? So the question of culpability becomes a major issue. As it is, we find today, for example, if you go to a police station to file a cyber attack FIR, he says this is not in my jurisdiction because the person involved is in the US. You have to file a thing in the US, not here. Now the point is, I am here. My identity, or I am the sufferer. I am giving it, but the police take the opposite view and say there's nothing to do with us because the person, the criminal, is somewhere else. So this kind of problems do come up. So who is responsible? Now Big Brother is watching. The Big Brother thing came from Animal Farm, I think, way back. George Orwell's book. He first talked about Big Brother, and today it has become a reality. You are under surveillance is something that you find all over the place nowadays, even in India. Which is why the seat of the US government, the capital, is not connected to the internet. It has got completely independent from the entire internet system. That is in order to protect the seat of government in the US. Okay, so overall, in a smart city, now you find that you've got an idea that all of this is all linked through the internet, information and communication technology and the internet cloud. How? This is what happens. Everything is in contact with everything else. Everything communicates with everything else. Information is constantly flowing 24 hours a day, 7 days a week, 365 days a year. And it's a tremendous amount of data that is being generated. And you need massive servers, you need massive storage devices. And all of this, ultimately, you have to make sense of it, which I told you about was big data. So you find that the International Data Corporation has predicted that 41.6 connected devices will produce 79.4 zettabytes, that is terabytes of information in 2025. And all of this information has to be processed and interpreted, which is what we now know as big data analytics. And this is a huge subject by itself, and you can Google it. There's plenty of information available. And this is the new big, field for students to look at. Okay, so this raises several challenges. The complexity of this whole thing raises several challenges for state and local governments, which may or may not be equipped to handle all of this. So this is where the smart city concept becomes very difficult to implement, because there are so many issues which come up in making a truly smart city, that is a truly interconnected city, which we call a smart city, where everything is smart. It is almost impossible to have it because the resources that you require and the problems that you have are so many that achieving all of them in a seamless and integrated manner becomes almost impossible. So there are very serious challenges for state and central governments. Okay, So at the end of it all, do we have something called a smart city? Creating a smart city with all its complexity is a phenomenal task, as we have seen. I mean, I think by now you would have appreciated that. No wonder then that the highly respected Scientific American magazine in 2017 said the movement towards smart city attempts is an attempt by public and private industry to tackle the complexity and oftentimes incoherence of urban design efforts to create livable and sustainable communities. The potential of smart cities should be to deliver on their goals, but it is not the reality of smart cities. The reality is that there is no such thing as a smart city today. At the end of the day, most of the so-called smart cities are just cities with a few or several standalone smart projects. That means you may have, for example, a smart communication for, let's say, hospitals. Within the hospital, you can have a smart system and so on. But the whole city is not wired. Locally, in several areas, you might have smart functions, but to have an integrated or a pan-city kind of smartness is still very, very far away. So today we don't have a completely integrated smart city. We have basically cities with some smart features. That is the current reality of what is known as a smart city or smart cities. Okay, we found that the 20 global smart cities, again, it depends on how you measure your smartness. So depending upon what yardsticks you use, your smartness, your ranking will also change. So in 2017, the Juniper Research conducted a survey and they ranked 20 global smart cities on the basis of mobility, healthcare, public safety, and productivity. And this is what they got. So in this, you will find that Bhubaneswar also is the only Indian city which features in the top 20 smart cities based on these four, key areas that we have got here. Now, in 2020, the IMD and Singapore University conducted a joint survey, and they ranked the 20 top cities based on infrastructure and technology pillars, which were also basically on the basis of the same 4 or 5 key areas that we had. And on the basis of this one, we had a different ranking. And in this, of course, you find India is not there at all. So it depends on what are the criteria that you use to rank your cities, and the ranking will change accordingly. But this gives you, nevertheless, a sort of a feeling. For example, Singapore is on top in both cases, and there are differences here in both of these. Depending on this, again goes back to the previous slide where we talked about smartness, certain smart features being incorporated in certain in cities which are already there, but not pan city smartness has not been achieved. Certain parts of it have become smart. Okay, that brings me to the end of the first part of the presentation, which gives you the technological basis for the smart city concept and how technology plays such a major role. I'll try to finish this quickly. Now we come to India's smart city program. This is not going to be as detailed as the previous one, but nevertheless. So here, this is what we will have: smart cities mission, smart city guidelines, implementation strategy, selection process, international participation, major challenges, current status, and conclusion. So as we saw earlier on, because of the massive urbanization and people have moved massively into cities, it has created serious problems. And as we all know, governments are bending backwards and really suffering in order to govern these increasingly ungovernable cities. And a lot of rules are given the go by, and as we know, the governments are taking shortcuts in order to solve their problems. And people have happily violated all the regulations, and the governments have gladly regularized those violations, because first of all, there is, of course, we have a lot of corruption. They regularize the violations because it's also a source of revenue. But the problem is why governments are sort of not so happy with smart city programs is because the control that they have now over local areas disappears, and it becomes much more transparent, and centralized control goes elsewhere. and you cannot tweak the system the way you can do it now. So that is one of the problems in India, smart cities in India. So in 2014, Mr. Modi included his vision for a radically new India by creating 100 new smart cities. And he said cities in the past were built on riverbanks. They are now being built on highways, but in the future, it will be on optical fiber networks and next generation infrastructure, which is a very visionary statement that he made. So his plan was to create 100 smart cities which would provide core infrastructure, decent quality of life, sustainable environment, application of smart solutions, and sustainable inclusive development which can be replicated across the country. And so basically it was trying to improve the life of the Indian, the average Indian, by giving him several tools by which his life can be made more livable and more enjoyable. So it is a sort of a very limited, very practically and pragmatically limited vision, unlike the overall smart city that we have been talking about for the last 1 hour. So this was later called the Smart Cities Mission, and in order to support that, he also started a tremendously important initiative called Digital India. All of these you can Google on the net and you can get tremendous amount of information. So the Smart City Plan now proposes to intervene and bring some order to upgrading infrastructure in select enclaves and using information and communication technologies. You see the thing here. We have already got legacy cities. We have got cities which are hundreds of thousands of years old, and you cannot make them overnight into a smart city, into a modern smart city. So pragmatically, what they are thinking is you start intervening and taking limited actions in limited areas and upgrading the physical infrastructure in certain specific areas, and you start incorporating smart features into those local areas. So we have basically two types. One is what we call the local area improvement, and the other one is pan city improvement. They are two different things, and that is the Indian Smart City program has components of both. So he proposed to have 100 new cities to be completed by 2035, with the first 20 to be completed by 2020, which has not been achieved. We'll see why. It has now been postponed to 2023. And to this end, the government wanted to contribute 96,000 crores, with 48,000 crores provided by the center, and the balance 48,000 crores to be generated by the states. This will be released to urban local bodies and environments over 5 years from 2015, with 100 crores, which is actually a very, very small amount for any city to start work. I mean, 100 becomes 200 because state also has to give 100. So with 200 crores per year, that is 1,000 crores in 5 years, what can you really do? These are all massively expensive programs. And is it possible for you to, for the governments to provide this kind of money? And you require much greater resources, financial resources, to implement the smart city components, which we saw earlier. So he then announced an investment of total of $1.2 billion in smart cities, with more funding coming from private sectors and abroad. So ultimately, the private sector has to get involved. It cannot be, as I mentioned earlier, a totally government project. So the total cost of smart cities for 20 years from 2015 up to 2035 is 700,000 crores. It's a massive amount of money, but the interesting part of it is that in today's world, we are not scared by these numbers. I remember when I started working in government 25 years ago, when I first came across 5,000 crores, I thought it was a huge amount. And then when I looked at the GDP of India, it was several lakh crores. And I said, my God, what kind of number is that? But today we very easily talk about city projects costing 30,000 crores or 50,000 crores, metro projects costing 75,000 crores. I mean, without batting an eyelid. For example, your high-speed rail system between Ahmedabad and Bombay and Ahmedabad is expected to cost 1.25 lakh crores. These numbers don't scare us anymore. And we have become very comfortable with these numbers. So this is going to cost 7 lakh crores, 700,000 crores or $100 billion over 20 years from 2015. But the international consulting firm Deloitte estimates that the mission requires $150 billion over the next few years, estimating that $120 billion will come from the private sector. Now, Whether you really be able to achieve that kind of number from the private sector is debatable. Okay, the government's idea of smart cities is quite fairly simple. It is ultimately a business proposition. Smart cities are those that are able to attract investments. It means any city that works well, especially for businesses. So the focus, from the time that Modi announced it in 2014, as the ideas started blooming and as they started evolving, the ideas also started changing. Ultimately, the ease of business started taking greater predominance. And today, smart city is one that, is considered to be one that is able to attract greater investments. And therefore, it is becoming more business centric. Of course, in order to attract more business, you also need good quality infrastructure, transparent online businesses, public service processes, e-governance that is very efficient, very greatly required, and it has to be run efficiently without bureaucratic hassles, and it must have greater transparency, and it must be citizen centric and investor friendly. Basically, you are trying to provide a system where a businessman feels at home and he is not hassled by a number of rules and regulations and so on and so forth, which are quite often incomprehensible. And he should be able to do this without having to approach government at any point of time. So if you are able to do this automatically, then to that extent, the businessman is more happy and he'll be willing to conduct business in your city or town or country, and therefore the economy of this country or the city or the local area will also grow. Originally, it was supposed to be totally new greenfield projects. When it first started, they thought of building a smart city from scratch. So you look at trying to allocate some 2,000 acres or 5,000 acres, and you build a new city there, which is completely smart. From scratch, you build everything in order to make it smart. But, the costs become extremely high. And as the plans evolved and as the challenges became better appreciated, the SCM, that is Smart City mission, underwent a modification to brownfield projects, which basically means you take existing cities and you upgrade them to become smart. Again, I'm putting smart in quotes because you don't make the city smart, you only make certain parts of it, certain local areas smart, or you incorporate certain smart features in certain systems. So it is not that the entire city becomes smart, only some parts of it or some components of it become smart. Or you have smart, smart provisions in certain aspects of city. So there is a change. There's an evolution that has taken place in the thinking of the government. I'm sure later speakers will be able to, especially the gentleman who is going to talk about policy and planning and so on, he will be able to talk more about this. I think that is Dr. Ravi, who's going to talk about planning aspects and public policy. I think he'll be able to throw more light on the government's vision of what they intend to do. So Digital India is a parallel and simultaneous development that is taking place. In fact, it's taking place very rapidly. Envisages making India a leader in digitally delivering services in the health, education, and banking sectors in particular. So again, you will find a lot of information, very useful information on the internet. In fact, the government of India also has set up very interesting and very informative websites which you can access. Smart City Guidelines. On 25th of June 2015, the government of India issued the Smart City Guidelines. Incidentally, this is freely available on the web. It's a very interesting document. You can download it. Smart City Guidelines and the mission statement of what they intend to do. So this set out the vision for the government's program of smart cities. The core infrastructure of a city would ensure adequate water supply, electricity supply, sanitation, solid waste management. What you will notice here is these are all things which are already there. The smart city program only intends to make them much better. For example, a very simple thing for today is, for example, in the case of solid waste management, I am told in Bangalore, the Bangalore Municipal Corporation is now going to put in GPS GPS transmitters on all the trucks, so that their position is known and so on and so forth. And it's going to be further automated in order to find out how much load they are taking, where they are taking, when they are taking, and so on and so forth in real time. So that is the kind of intervention that is taking place. Then we have, of course, the electronic part of it is here. What you find here is IT connectivity and digitalization and e-governance. This is, of course, now as we are already seeing, the government has put in place a large number of initiatives to make people be able to do work online than having to visit government offices as we used to do earlier. So e-governance is becoming more and more prevalent, and these are all things that were there earlier, except that they are being given new emphasis and new push. So it is basically upgrading existing services and putting in smart features wherever it is possible in order to have much greater centralized control and also much better information gathering and information analysis. So that is basically what the smart city mission envisages. So again, this is a slide that you will come across everywhere. It just gives you a broad overview of the kind of smart city services that can be incorporated in cities. Okay, this is the timeline that we have. In 2015, they announced the smart city program, and they had a national conclave in end of September of 2014. And 2015, the city challenge was announced. And in 2015, again in February, end of 2015, February, they allocated 6,000 crores for the smart city mission and the ATAL mission. And in 25th of June, 2015, they announced the smart city guidelines, which we saw just now. Okay, many of the requirements for smart cities are already here. We are all familiar with what you follow here. These are all things which you are very, very familiar with. It is now a question of having to integrate all this into our city systems. These are all there. The electronic basics is already here. So we are familiar with almost all of them. And now what remains to be done is to incorporate all these things into the smart city, interventions that we are going to do in cities and incorporating them into our systems and services. Okay, the implementation strategy, the fourfold strategies that they have. One is retrofitting, which is taking an existing built-up area of 500 acres or more, jointly identified by citizens, government, and urban planners, for redevelopment through urban planning to introduce smart city concepts to make it more efficient. Again, this is incorporating smart city concepts in certain areas in the city. For example, smart signaling will be one of them. Okay, now redevelopment. Here you take much smaller areas where you take 50 acres or more, and here you actually, what you do is you demolish the area, you remove the existing system, and you create a new layout with enhanced infrastructure. So it is the same original concept of the greenfield idea that they wanted to build a new city. Instead of that, they are going to take an existing small area, demolish it, and then rebuild it with smart features. And you have much better infrastructure that is built. An excellent example of this is the Bhendi Bazaar project, which I think Mr. Gopal Krishna or somebody touched upon it, or maybe it was another lecture. Anyway, here, this is a private initiative that has been taken up by the Bohra community in Bombay, where several people died when the building collapsed in the Bhendi Bazaar area. And so what they did was, the Bohra community in that area, which who are predominantly the majority there, they took a decision to rebuild the entire area and bring in brand new buildings and relocate all the people, 20,000 people living in 250 crumbling buildings which would be demolished, and locate them in 13 new high-rise towers to be built in the same area. And the entire thing is being privately financed. So this is what we have. This is the existing thing which they are going to demolish, what you see within the red quadrangle, and that will be replaced by this. So this is what is meant by the redevelopment or city renewal process that we have here. So this, they will take a location by location, identified by citizens, government, urban local bodies, and so on, and then it will be demolished and then rebuilt. So this is the second way of improving city life. The third is greenfield development, which is city extension. So basically, you take 250 acres or more within or outside a city, which will be developed to incorporate as many smart city concepts as possible with innovative planning, plan financing, implementation to land pooling, etc., etc. And these are all greenfield developments which are required around the city, not within the city, in order to address the needs of expanding population. One of the best examples of this is Gift City in Gandhinagar. I think you can Google that also. It's a remarkable achievement what they have done there, and it is already operational. So it's a completely new project, and it is really very smart in all its aspects. I think another city is the Lavasa project near Pune. That is also, sorry, is it not moving? Are the slides not moving? Hello?
Sir, go ahead, sir. No problem.
Okay, because somebody put a note to say it's not moving. Okay, then we have Pan City developments. Kalgal is saying it's not moving. I don't know. Is it a local problem?
It's not the slide, sir. It is Gift City, sir. Wants to mention.
No, what is the problem here? Okay.
Sir, it's no problem with the slides, sir. Sir wants to mention that Gift City is not moving forward.
Oh, I
That
see.
he
I
was
see.
trying
Oh,
to
I see.
mention.
Okay, okay. I
Yes.
thought that my slide was not moving forward. Okay, then we have Pan City development, which is selected smart solutions through application of innovative technology, information communication technology, which we had discussed earlier. And these include citywide. These are across the city. Citywide internet and Wi-Fi availability, intelligent transport systems. This is a much longer term kind of activity that is going to be done. At the moment, I don't think we really got much activity in this area. What is actually happening is, and all of these are intimately connected with the digital city. So the 9 pillars of digital India are what you see here: broadband, highways, universal access to mobile connectivity, public internet access program, governance, e-governance. Then we have e-Kranti, which is electronic delivery of services, information for all, electronics manufacturing, IT, electronics manufacturing, IT for jobs, early harvest programs, and so on. So these are, again, if you go to Digital India, you'll get details of each one of them. So this is what you have. I won't read that. You can get all of this on the net, but it gives you the components of each of these things, of what each of these names mean. Okay, to manage all this, the Government of India has set up a 3-level or 3-tier management system, which is one is at the central level, the Apex Committee, which is chaired by the Secretary of the Ministry of Urban Development. But the role of the Apex Committee is basically advisory, and they will lay out the overall policy and so on and so forth. And the members will be other government departments. Several government departments will be part of the Apex Committee, basically through their principal secretaries and so on. Then we have invitees, parallel organizations like UN Habitat, World Bank, CDAC, TERI, and so on. Now, under this, you have the National Mission Directorate, which is the next lower level, but which is also a central authority, which will have a chairman who is of not less than a joint secretary rank. And while the Apex Committee is advisory, the National Mission Directorate will be the implementing authority as well as the monitoring authority. So basically, they will act under the supervision and advice of the Apex Committee. Now here, these constitute the national level tier of governance for the Smart City program. Then we have, under the National Mission Directorate, we have a high power steering committee for every state, for each of the states. So this is headed by the Chief Secretary of the state government, who will be in charge of ground level monitoring, ground level implementation and monitoring. So it is the next lower level. And they are in charge of direct implementation and monitoring of the projects for their state. So here we have, again, like the central government, we have government departments as members, and we have the same structure for all the states in the country. Under the state power, now this is at the state level. So this is a second tier that we have in the management structure. Under this, we have the actual implementing authority, which is the Smart City Advisory Forum, or which is a public-private partnership. A new SPV, special purpose vehicle, is created. It's a separate company that has to be created, which will be actually in charge of the implementation of the smart city proposals that the state has made and which have been approved by the central government and for which funding has been received to be actually built on the ground. So the CEO of the SPV becomes the point man responsible for the actual implementation of the smart city program or the smart city proposals for each state. So every city will have a CEO for that city. So you will have one for Bangalore, you'll have one for Mysore, you'll have one for Pune, you'll have one for Delhi, and so on and so forth. So each of these SPVs then will be in charge of implementation monitoring. Now, for this, you will have the members of the residents' welfare associations, societies, NGOs, and so on, trade unions, whoever has got a stakeholder interest in the development of that city will be members. And the same thing is produced for every city under every state. So this is the kind of three-tier, and as I told you, this Smart City Advisory Forum is a public-private partnership, which itself raises some questions. So this three-tier system is the overall structure for management of the smart cities mission. Now, the government of India then took a decision to distribute the 100 smart cities on an equitable basis, giving equal weightage to urban population and the number of statutory towns in the state. So the larger the state and the larger the population, the larger number of cities that it will get. So, for example, if you got some states like Manipur, which will probably have only one city, but whereas states like Maharashtra will have 10 or Uttar Pradesh will have 12. And depending on the strength of the size of the city and size of the population and the number of cities which you have, the number of 100 cities was distributed among them. Now, distribution formula for allocation of funds under the ATAL Mission for Rejuvenation and Urban Transformation, AMRUT, is the agency for distribution of funds. Now, to select the city, they announced this Smart City Challenge, which went through 4 rounds rather. Now here, they had a 2-stage selection process. So they had the intra-city challenge, where basically within the state, cities were asked to compete to give proposals to the state of what they felt would be an upgradation of their system under the smart city program, for which they could source funds from the center and the state. Now the state government then shortlisted a certain number of cities based on the guidelines of the smart cities mission, and then that was sent to the central government for the second stage competition, where the National City Challenge was selected to get the winners of the 100 cities that was planned. Now, this is a picture that shows you the round 1, round 2, round 4, and the number of cities that were selected were 200, and the total investment was 2,05,018 crores. So that is the total investment that has been allocated. So the average smart city project for each city was 2,050 crores. Okay. Now here, this gives you a breakup of cities across states. So Uttar Pradesh, as you find, has got the largest number. Tamil Nadu has 12, Maharashtra 10, and so on and so forth. Ultimately, these are all the smaller states which have got 1 each, and the total adds up to 100. So this is the kind of breakup that we have for the 100 smart cities. And this is just a graphical representation of the same thing. And this is how now the first list of 20 smart cities is supposed to be completed by 2021. It has now been extended to 2023. And this is the list of cities to be completed under the phase 1 of the program, that is 20 smart cities by now 2023. And of course, quite a lot of them are actually moving very fast ahead. Others are lagging, as we'll see later. Now, funding for smart cities comes like this. There's a slight discrepancy here between the figure quoted by the Government of India in 2000 and what is given here. This is taken from the one of the reports that I had, which gave this number. but there is a difference of about 1,000 crores. I'm not sure exactly where that difference lies, but this is the kind of breakup. What you see here is that we had central government giving 48,000 crores, urban local bodies and state giving 48,000 crores. Now, the other funding programs that we have in India are 42,000 crores. And then the rest balance comes from public-private partnerships, loans, their local bodies' own resources, and so on and so forth, and other undefined sources, maybe bonds and things like that. In fact, there's a detailed list that you can get on the net for this. Here we have, for example, note 1, which is this one, other own resources for the city, which is user fees, parking charges, land monetization, debts, loans, etc. And this is from the note 2 is the 12,500 crores from incremental financing, rated municipal bonds, and so on and so forth. So this is the broad picture of the funding for the Smart City program. Now, several countries have also expressed interest in the Smart City Development Program of India. And here you get a list of countries and the cities that they are going to take part in various forms. It can be funding, it can be technology transfer, it can be actual participation in building up the city, and so on and so forth. So there are a number of different countries are taking part in the development of India's smart cities. Now, this gives you a distribution of the cities. It's pretty uniform, pretty distributed, well distributed. Okay, now we are coming to the end of the talk. I am trying to race actually. Now, all this is very fine. We have got all these grand visions. We have got all these great ambitions and so on and so forth. And we have also got this tremendously complicated ICT, information technology, communication technology system that we have to incorporate. How ready are we? How much have we achieved? What is our problem? How far are we moving? Let us see. Now, this list that you will find has been taken from a number of different sources and collated together. So they are not all of them in one place. But I have tried to arrange it in some fashion so that you get an idea of how major the complications and problems are, which are quite often, which are in many respects unique to our country. Maybe there are other countries which have similar problems, but we know our problems best. And I think all of us here will be able to appreciate and immediately recognize these problems for what they are. First of all, the biggest criticism against the smart city project is, especially by quite a lot of the architectural community and others, is that it lacks clarity in conceptualization. They are saying the basic concept of the smart city itself is not clearly understood by government, and also they are not clear about how they are going to incorporate ICT in the development of smart cities in India. Again, there are detailed explanations available for each of these things in the web. Then there's a big problem of perception and appreciation. What the government thinks and what the babus and the people planners and others at the high level think is one thing, and what the people at the receiving end or the people at the implementing end think is quite another. So not everybody appreciates the same grand vision that is being looked at by the government of India at the local level. For example, if you take the local urban local body, they don't quite gel with what the government is planning to do. So there is a fundamental difference in the perception and appreciation of the goals of smart city program and the realities at the ground. So the people look at the smart city program from their own limited perspective of the local conditions, and this difference is where the major problem. Okay, then we have, which is the right model. Now we as Indians are very good in debating. We will debate a subject to the death, but will not allow anything to happen. So that is one of our strengths. So here, the right model for smart cities is again a major question. And people are asking, there are so many models, which is the one that you're going to use? And the problem is, whichever you use, there is a problem with it. So what I'm saying here is that it's only a question that whether the particular model that the government has chosen is the right model or not the right model is a debatable question, and that debate continues. Then can there be a single common approach? Obviously not. I mean, what works for Bangalore may not work for Pune, or what works for Pune may not work for Surat, or may not work for Manipur, or may not work for Guwahati. So each city is a different organism, each city is a different being, and you need to tailor your smart city programs according to your local requirements. But that is one of the things. When the smart city challenge was called, it was ultimately from the proposals were ultimately given by the cities concerned. So obviously they have given something that they think would be suitable for your particular local area. But as in everything else, the high level view is that perhaps some of these things can be made common, and therefore you issue guidelines to making them common. But this is again a debatable issue. Then social acceptability, livability, and sustainability. These are, again, social acceptability, again, like the problem of perception, has become a problem. Here, one of the problems is who benefits most from this. There's a lot of criticism in the what do you call, in the web, in the open media, about the fact that the government has gone ahead with this program without adequate stakeholder consultation at the living level, at the level of the city and so on. No doubt the proposals have been given by the cities themselves, but nevertheless, they feel that when you are formulating an overall policy for the entire country, there should have been a much greater level of stakeholder consultation, which has been missing. So the criticism is that perhaps this smart city mission is being structured by people who live basically in ivory towers, who are not familiar with the ground level realities. So this is one of the problems that also is the smart city program is facing. Then, will these smart cities cater only to the urban elite? How many poor people can afford to a high cost of living? This comes from the fact that these are all very expensive programs, and you have public-private partnerships taking part in this. When the moment you bring in public-private partnership, then questions of tariffs and fees and costs will come in. And since these are all very expensive programs, does the man on the street ultimately benefit from it? Or is this, and keeping in mind the fact that the smart city program is sort of business-centric or business-oriented, does the ordinary man on the street get any benefit? This is again a question that is being asked. In fact, there's a lot of doubts that have been expressed on this issue. Okay. Then another major problem is shortage of town planners. The smart city program requires a tremendous amount of town planning and proper allocation of funds and so on and so forth, and proper working. I mean, the projects that have to be implemented have to be done in a holistic and a unified manner. And the Ministry of Urban Development has estimated there are 5,500 town planners working in the country against 1.1 million that are required. This is as per the Urban Development Department in order to make the smart city work. So we have a very, very major resource crunch, in manpower resource crunch, as far as the implementation is concerned. Then we have program design, operation, and institutional requirements. A big problem is three-tier governance. You have the central government, you have the state government, and then you have got the the city level SPV. So you have problems with between SPVs. Who controls? Ultimately, who takes the decisions in the implementation? Urban local bodies feel threatened that their powers are going and being handed over to a public-private partnership, which is a SPV. Then lack of coordination, which we are all very, very familiar between implementing agencies. Then we have multi-vendor environment where you are going to source equipment from various different people, and you have problems of standardization, you have problems of different groups of people giving different ideas and so on, equipment and so on. So there are major issues in this. And one of the big problems in this area is the fact that the majority of Indian cities do not have a master plan, a master city development plan. And some of them are old, some of them are not even prepared. And so we have a major problem here. So this is one of the problems in actually implementing the smart city program. Then lack of transparency. This I don't need to say much. Government claims versus ground reality. In fact, I shouldn't say this, but what is happening is the smart city program, a lot of funds are coming in, and a lot of work is being claimed to have been completed at the ground level. But when you actually go and look at it, it's not been done. So what between what the government, whether it's the state government or central government, what is claimed is quite different from what actually has been achieved. This, of course, we are all very familiar in India. I won't elaborate more on that. Then we have got, in addition to the smart city program, we also have several other national development programs. So the question is, how do these two dovetail into each other? Will there be a conflict between the overall national development programs and the smart city development programs that we have? Is there a problem? Is there a convergence or no convergence? So this is a problem. Okay, now in fact, now here we have, okay, now then we'll go to the next one. We have funding strategy for smart cities. It's a very, very major problem. We have already seen the kind of money that is required to implement this program. And most urban local bodies cannot raise the kind of funds required. They are all suffering as it is. We are all very familiar with our municipal corporations and the municipal local bodies, how tremendously short-changed they are, and they don't have any money. So in that case, how are you going to find funds when they are not unable to manage what they are managing them right now? If you don't have funds to manage what you have got right now, how are you going to find funds to manage or build new systems which are required in the smart city program? So this is a major, major problem. Then we have the other major problem is technology-centric reforms. Ultimately, as I said, the whole thing is technology-driven. Not everybody understands technology, nor are the urban local bodies able to deliver. The urban local bodies consists of not necessarily technical people, but they consist of people, administrators, and so on and so forth, who have no understanding or appreciation of technology, and this requires a very technological approach. So, are you able to deliver the technology-centric reforms that are required to make cities smart or even local areas smart? So, this is a problem. And lastly, achieving good governance. This is a thing that the government of India has emphasized, and good governance would require a participatory approach for men and women and people in the city to express themselves freely. It must be consensus oriented, it must be accountable, it must be transparent, it must be responsive. That means for any grievance of the public, the government should respond immediately. It must be equitable and inclusive, and it should follow the rule of law. Now, all of these things have to be done for good governance. How well and how effectively these are done determine to a great extent how well the program will succeed. So we are coming to the end. The Smart Cities Progress Report, 4 years into the mission, 933 projects, only 18% have been completed. Work orders have been issued for 1931 projects at 37%. Tenders have been issued for 827 projects, constituting a total of 71% of the total, worth about 1,36,000 crores. So this is, this was supposed to have been completed. The first 5 years, it's supposed to have been completed. 20 projects have to have been completed in 5 years, but we are nowhere near that goal. We are only 70%, and of which only 933 or 18% have been completed. The rest of them are still work orders and tenders, so it is yet to be taken up. So till 2019 July, of the promised 48,000 crores, only 17,000 crores was released, and only 6,000 crores has been utilized, a mere 3% of the total estimated costs in 2015. It just goes to show you how many difficulties there must be in actually using it, and how many problems have not been addressed as yet, and how many problems are facing the implementation program. So as of September, this is what Mr. Kunal Kumar, director of the Smart Cities Mission, has said. As of September 2019, out of 51 projects that 100 cities have proposed, we have tendered out 3,880 projects, grounded, stopped 3,100 projects, completed 1,100 projects at 201 billion or 20,000 crores. So the remaining projects are expected to be tendered out by March. So there is still a long way to go. In 34 of the 100 chosen cities, not a single project has been completed, despite 4 years having passed. Under public-private partnership, 65 projects of 2,000 crores have been completed, 116 projects have been implemented, are being implemented, 91 projects of 9,600 crores are in advanced stage of tendering. So ultimately, this comes to 53% of the total funding of 41,000 crores, which is under process. This you have already seen, that we require a great deal more money for this mission to succeed. Besides, the progress of the mission has not been geographically uniform. 54% of the projects have come from only 4 states: Karnataka, Madhya Pradesh, Gujarat, and Uttar Pradesh. And as of July 2019, only 10 cities constitute 48% of the completed projects, as you see in the graphic on the right side. And these are New Delhi, Belgavi, Surat, Indore, Varanasi, Raipur, Tumkur, Vadodara, Ajmer, and Ahmedabad. Only these 10 cities are moving fast ahead. And of course, Pune is also there, but this has not been reflected here. So these 10 cities constitute the bulk of the completed projects. Some of the principal reasons are, of course, as we have seen, non-performing ULBs, slow pace of fund generation, and long gestation periods for funds and for these projects to take off. Many Indian cities are struggling and yet provide even basic amenities like proper roads, lighting, and so on. And so several cities are actually using the smart city funds to take care of their individual problems of what they're supposed to do. So because they don't get funds, they are unable to raise funds for taking care of the normal day-to-day work. They are using smart city funds. This is the thing that came up earlier between the perception of the report of the government versus the ground reality. Actually, I don't want to say this, but the reports, the web has been quite critical about the fact that misreporting and underreporting and false reporting have become quite rampant. So this is where another problem is going on. So we come to the end of the presentation. I've stayed within my time. In spite of all the worries, there is much to be said for smart cities and the digitally interconnected world. But many serious security and privacy issues are there which need to be addressed and which we are not even touched as of now, at least in India, or for that matter, anywhere else in the world. I mean, they are being looked at, but the problems are immense. Amsterdam, Barcelona, Birmingham, and other cities are all, and many others are shared to, have an aspiration to become smart cities in the true sense. But none of them have become. Singapore, London, Helsinki, and others have well ahead and have implemented many smart schemes. Again, to remind you, these are all cities that have implemented certain smart schemes, but not the city itself has become smart. More than 500 cities all over the world have set the same goal for themselves. Several Indian cities are trying very hard to introduce smart features in Indian infrastructure, for example, smart metering, and many cities have progressed a great deal. But there's a long road ahead for India before we can have truly smart cities. What we will have, though, because of the smart city program, is much better cities than what we are used to. We are already seeing that in many aspects of our lives, and for that, I think we should be thankful. Of course, India also hopes to join the world with an ambitious plan of smart cities. We as Indians have a lot of hope. Let us hope for the best. Thank you. Any questions?
Thank you, sir. The concept of smart city is a very broad term which highlights the integration of resources and networks for sustainable and safe living. Is presented with a lot of analogy, data, and illustrations by Sri B.S.C. Rao sir. So, due to the overshooting of inaugural session, we request the participants to post your queries through email, and we will connect you to BSCR, sir.
Oh, incidentally, for those who might want to have a copy of this presentation, I have sent a link to Dr. Bharati Ganesh, and if she would like to share it with you, you can download it from my Google Drive. It's available in a PDF form. You can download it if you like. That is
Thank you, sir.
provided the link is posted.
Sure, sir. Thank you.
So, with your permission, now we shall go ahead to the next session, that is on considerations for planning and implementation of fire safety in smart cities by Mr. Abhishek Chabra. Now, I would like to call upon my colleague, Mr. Manjunath L, Assistant Professor, to give a brief about our next speaker.
Good afternoon, everyone. I'm very glad to introduce Mr. Abhishek Chabra, sir. Mr. Abhishek Chabra, sir, is presently Market Development Manager, Thomas Bell Wright International Consultants. He joined Thomas Bell Wright International Consultants in 2013 and has been driving force behind the expansion of the fire compliance activities into markets. An engineer with a postgraduate diploma in finance, Abhishek brings with him experience from other larger testing, inspection, and certification companies. He has been advocating compliance to standards and quality across India for most of the last 18 years. Experience of how conformity is realized across several industries, including consumer electronics, renewable and building products, along with helping certification bodies and their horizons of business for over has been writing articles at about voluntary quality and safety compliance activities. He has also drives a blog called Gurus of Testing, Inspection and Certification, aimed at expanding the understanding of conformity across the world. So we are very glad to hear your presentation, sir. Thank you very much. Yeah, sir, you can go ahead with your presentation, sir.
Okay, finally, I am unmuted. Thank you very much for a lovely session, Mr. Rao. It was quite an informative and a massively huge data set. And of course, I will be talking not so much about so many aspects, but what I intend to do is I intend to talk about a very critical and important part of the city development as a process, which is I am going to talk about fire safety, something which is very deeply rooted into urban planning, city development, and several aspects which are talked about by you in the last hour and a half or so. Just a quick feedback from the listeners that you can listen to me and the voice is clear and you can see the screen would be very good and helpful for me. Am I audible?
Yes, sir, you are
Perfect.
audible and your screen is perfect. Yeah.
Thanks, Manmohan. So I believe that over about the 100 odd people who are listening in today, a good percentage of all of you would be taking some very critical decisions in the next 30 years in your life, which will contribute hopefully to the development of smart cities in our country and probably even outside of the country. So some of the things that I will be talking about may seem specific to the context of fire safety, but I would encourage you to think beyond and understand some of the concepts that I will be talking about, mainly codes and standards and concepts related to compliance and conformity assessment. As a lot of students who are listening in, and students need not necessarily be people who are in education, but we are, as all of us are students forever in our lives. So I will be talking about several concepts which are related and are important in implementation as well as planning. Thanks for the wonderful introduction that was given earlier. This is me, an engineer and a PG in finance, and I have worked across the supply chain of several industries, including semiconductor, heavy engineering, consumer electronic products, renewable products, and my latest love in the last 7 years has been fire safety. I have been involved in several aspects related to compliance and conformity assessment for fire safety, members of some of the standard writing bodies, code writing bodies, accreditation bodies, as well as I was introduced, I run a blog and a website called Gurus of Testing, Inspection, and Certification. And what I am going to talk today is all in some or the other way related to compliance and conformity assessment. And we know that in order to do any compliance or conformity assessment, we need some codes, some standards, and some guidelines. As Mr. Rao was also talking in great detail about ICT as a segment, codes and standards are everywhere. Right from USB 2.0, there is a standard behind USB 2.0. And just about everything that you see around you, there is a standard that has been issued to bring about lots of different aspects: quality, safety, conformity, trade, etc. And then we will center all of these discussions around a core concept of fire safety in smart cities. And that is the core subject for the day. Almost everything that I will be talking about has a very strong link with the development and the construction of infrastructure, as well as a lot of other entities and projects that really require to be fire safe. Fires have become much more common as a problem when it comes to high rise, as new and different materials come into play, and as technology fast forwards in front of our eyes. So in today's session, I plan to connect these dots, but along with connecting these dots, I will also be touching upon several critical aspects, codes and standards, smart cities. Mr. Rao helped us understand to a great detail how and what smart cities are. But some of the related things that I will be touching up today is pacifier protection. We will understand how supply chains of materials work and what are the areas where all of us should be very, very careful and cognizant of. The sessions and the slides that I will be presenting and the talks that I'm going to share with you intend to open several doors, intend to open several directions of learning, implementation, as well as efforts which can lead to not only the progress of individuals who are attending in their lives and their careers, but it will lead to a massive amount of progress and upward movement of our country, which is India. Let me start with giving almost kind of a background of terminology. Some of the words that we use, like standards and codes, are very often let around without people comprehending the intensity and the implication of these words. I'm assuming many of you have heard ASTM or NFPA or any of these abbreviations which define standards and codes, or ISO is something that is very, very familiar. But all of these standards, codes, they typically get grouped into 3 types, and it is important to understand what it really means. The National Building Code of India is a document that some of you may have seen or would have been familiar with. It is a document which is defined as something called a code of practice. And what is a code of practice? A code of practice is recommended good practice, currently undertaken by competent and consensus practitioners, which means this document would typically define the minimum requirements to be fulfilled as per the current understanding of the geography and the people who have been involved in creating a code of practice. A bit of a background, the code of practice, which is the National Building Code of India, got initiated in 1965, as some of you may or may not be aware of, but such a code of practice has many, many international parallels. The NFPA, or the International Building Code of the United States, are one or few of similar documents. And these documents set in baseline guidance on how construction needs to be done, buildings need to be built, and bring in a huge amount of concepts which are required to be known and correctly implemented. So the standards of NFPA 101, for example, IBC, the International Building Code, are documents and guidelines which have been created as well as iterated for nearly 100 years. And hence, a lot of people in India would look at international standards, international building codes, as being much more appropriate. I must caution and bring in a sense of perspective. And before I get a sense of perspective, I must bring out that thousands of years ago, it is people from India who had been capable of coming up with extremely good building codes. The Vastu Shastras, or lots of documents which have been written close to 3,000 years ago, defined and understood the local requirement, the exact requirements of the state, the region, and the kind of people and the kind of practices that people were having at that point of time. And hence, I want to bring about a concept that is very, very important on matters related to codes of practice. The codes of practice need to be and should be local. Mr. Rao was talking about the fact that each city or smart city is different. City in Pune would be different from Surat, because each city is unique. And exactly in the same way, codes of practice for a given geography, for a given demography, need to factor in what is local, what is the requirement, whether it is requirements related to high salt content in the air for coastal cities, or the wind direction, or it could go up to comprehension of certain concepts of reality technology by looking at the demography of a city or a region in terms of their literacy and education on certain aspects of reality. The reason I bring this out is a lot of you will be using codes of practice in your work in the future. So you should understand what is the basis of a code of practice, how to use it, and where all there exists a certain amount of flexibility to change this code of practice. Another categorization is methods. Often, a lot of people would know test methods. These are very prescriptive documents. They set out an agreed way of measuring, testing, specifying something which is reliably repeatable, irrespective of the circumstances in which this is being done. As an example, if I talk about certain test methods, I will show you that here is a test method for reaction to fire properties as per an American standard called the ASTM E84. Now, the ASTM E84 is a standard for repeatably measuring how materials would react to fire and classifying their reaction to fire behavior. In the same way, there are several standards which would provide many different types of methods to capture a given set of information, namely in this case, a reaction to fire property. What this means is when we are talking about the standard or a standard method, we are looking at repeatability, irrespective of what material is tested, which part of the world it is tested. The methodology to test will be exactly the same, which means an exactly same environment will be created so that the two products or materials that are being tested in this case can be very equally apple to apple tested and checked. So these are methods. Moving on to another type of document, which are called guides. Now, guidelines documents are less prescriptive, unlike the codes, which are very, very prescriptive. These are advice, which again talk about the current thinking amongst experts of a particular domain. Through the course of the session, I will be talking about few different guides which are very aptly used world over for defining what is called conformity assessment, a field which is not very, very well evolved in India, but is extremely evolved in many other parts of the world, which means what in India usually talk about quality. But conformity assessment as a concept talks about the ability to validate and check the conformity against any kind of property. The property could be whether a product catches fire or not, but the property could also be weight. The property could be a physical property, a mechanical property, a performance property, or whether the product is safe or not, electrical safety, and so on and so forth. But those which are validated through test methods. But this categorization is guides. Why are they important? Let me give you an overview of a point of time many, many years ago when the World Trade Organization got in place and created lots of open doors for people to trade products with each other. And when this was done, many of you familiar with ISO 9001, as probably the only means to measure and assess whether the company you are dealing with is good or not. So this is where the guides came up. When the doors of trade opened around the world and people wanted to deal with companies they physically did not know or did not have a relationship with, they needed some method of measuring two organizations on an apple-to-apple basis. This is where the evolution of the ISO 9001 standard came in. And this standard helped a company look at another company by virtue of assessing whether they are following certain standard methods of every aspect related to that company, whether they are a manufacturing company, a service company, and so on and so forth. Moving forward, the next problem popped up. Imagine three companies in three different parts of the world making furniture or chairs. You may be able to assess whether these three companies are good and will live up to their financial, commercial, and technical commitments, and they have a process in place. But how do you really validate the performance of the product? While on one side, standards were evolved to test these products. As an example, for chairs, there were standards that developed to check whether the chair can take a certain weight, and let's say it has to undergo 600,000 cycles of a 150 kg weight dropping up and down on it. But not only that, there was a standard that evolved, which is ISO 17025, which would put the testing laboratories at par, which means if the product is tested in a laboratory in Mumbai versus if the same product is tested as per the same standard in a laboratory in Turkey or in a laboratory in Guangzhou or a laboratory in Tokyo, well, the standard is repeatably measured. And hence, this guide is a key to equating laboratories. So you must understand the tiers. There are standards which are used to validate the equation between two different suppliers. But this is a guideline document which will define whether there exists a parity between two different laboratories or checkers, if I can say so. But the problem could not get solved at this stage. They were very smart commercial entities or manufacturers of materials who would test a given sample and supply something else. So there came up with a need, which has been implemented much more in the last 10, 15 years in those products which are highly, highly risky. So as an example, in India, we are very, very familiar with the ISI mark, a mark which instills trust and confidence. Similarly, the concept of what we know as certification and listing was brought out about. Some of the logos or marks that you see on your screen on the right side are marks which are owned by private companies in the world who would say that we have gone to the factory, we have looked at the product, what is being manufactured, and we are providing an assurance mechanism. More on this in the later slides, and I will talk about this. But this slide is for you to bring about that among the hundreds of thousands of types of standards and codes, what are the kinds of guideline documents that help people bring about parity, about repeatability of supply. And this is extremely important when we talk about good infrastructure and cities which are going to come up in the next 50 years in our country. Is the supply same or not? What is the method available to the people who are key decision makers in our country to actually validate whether one product is equal to the other or not? ISO has a technical committee, which is TC 268. Some of you may be familiar with this committee. This is a committee that has been writing and developing standards. And these are standards which define several aspects of what sustainable cities and communities are. Why is this important? This is extremely important for all of us, not only because India's BIS is a member of this technical committee, it is also important because they have already published a standard which are indicators of smart cities. You, as people who are interested in smart cities in some or the other way, should not only be aware of this standard or these standards, but should consider participating and making sure that the Indian point of view comes into these standards. So with that, let me move to a slightly local understanding of smart. Mr. Rao is extremely helpful in bringing out that how certain buzzwords have come into practice, which are defining nothing specific, but just the normal natural. I don't know how many of you are familiar with the PSTN system of telephones. I know that all of you are familiar with, of course, what you and I call smartphones. But let me take this as a very basic analogy to drive a better understanding of smart and what it is. Probably Mr. Rao would be aware of, and a few people here would be aware of, the phones which you see on the left side of your screen, where at an era, maybe 30, 40 years ago, you would just pick up the phone and someone who was being an operator would answer your phone without having to dial anything. And you would tell the operator who you want to talk to. And that operator would be sitting somewhere and have a switchboard which looks like these cables that you see on the screen, and would connect your call physically with the other person. And over the period of times, this process has evolved and evolved and evolved. And we have what you and I call as smartphones, which connect people almost wirelessly. But it is important to know and understand that what comes across as wireless is wireless only in certain spaces. When you have a wireless connection, it means there are wires somewhere. At the bottom of the screen, you see some of the towers, which contain a huge number of cables. And the cabling is much less than what it should be, because a lot of cabling has moved from electrical copper cables to optical fibers and so on and so forth. But still, the cables related to power and data movement will always be there. And hence, I want to understand that when we are talking of smart cities, as very, very well defined by Mr. Rao earlier, is that smart cities are just better interconnected means of measurement and using this data, which means that as a city and as an infrastructure, we will require a much higher degree of this interconnection. So as a definition, I'm actually going to go back to a definition which was very, very old, 2014. And I'm going back to two different standards which define smart cities. And you can have a quick read, but the reason of showing this to you on the screen is to kind of open a door for all the listeners to know that there are standards and there is a reason behind standards existence to create a benchmark, and the creation of benchmark will help interoperability. The creation of benchmark will also help people to go beyond the standard. So a lot of link of standardization has got a link with progress. So an effective integration of physical, digital, and human systems in the built environment to deliver sustainable, prosperous, and inclusive future for its citizens. So in order to do all of this, and in order to deliver all these things of a massive amount of interconnectivity, and the slides in the previous talk by Mr. Rao goes to a great deal in explaining the technology, the ICT behind how this interconnectivity is becoming quicker, faster, intelligent, or smart. We should not forget the fact that behind the scenes, when the infrastructure is getting created, there will be a huge demand and supply of infrastructure related to interconnectedness. You may not have cables visible in front of you, but for data and power to get here and there, cabling is very, very well required. So because we do not want to end up in photographs, not only like these, but a plethora of such images that you can see, not on the internet, but when you go out or when you go into the service areas of your buildings, and you would prefer that the service area of your building or the building that you see next door right now is an extremely well curated and managed, like the image that you see on the right side. And let me drill down to why all of this is extremely important. We have another speaker later who will be talking about BIM, or how there is a huge amount of availability of this data, access in a digital form of what are the interconnections, where the cables are meeting, where the mechanical, electrical, plumbing systems are meeting, and all of that. But at the ground reality, apart from design, what is really important is when the building gets constructed, when the floor actually gets constructed, when the work is really done, a key aspect of fire safety, which is called compartmentalization, which means that in case there is a fire that starts off in a room, this room could be an office, this room could be a hotel, a hospital, a residential area. A key aspect to make sure that these fires do not wreak havoc and cause huge amounts of damage to life, to money, and several other aspects is a concept called compartmentalization. It is a means of fire safety and fire safety planning, propagated and talked about in almost all codes of building codes and standards. But what it essentially means is something that is of critical importance to all of you who will be taking key decisions in the next 30 years, which means that how a fire gets contained within one small compartment of a building and it does not propagate out. And it is good and important to know and understand how this will be done. There are three aspects which are related to what we call passive fire protection. Containment, which means if in a room that you imagine there exists a fire which opens up, the fire gets contained only to that room and it does not spread outside. And this is something that is successfully done in many parts of the world. Limit the ignition and limit the spread of fire, how this is brought about and how this is done. And of course, what we call structural fire protection. As smart as we may become, we know that fire is a physical phenomena that will happen and can happen. And we need to move beyond to make sure that these accidents do not really happen. How is containment done at the ground reality? It is something that all of you should understand, because these are key aspects for anybody who is studying or is moving up in their career, because these aspects and better understanding of these aspects will lead to a movement in career. How is containment done? You can think of doors and walls and partition, but at the end of it, it is building material which is manufactured in a factory somewhere. Any finishing material, carpets, flooring, all of these have a massive amount of manufacturing in a chemical factory or so on and so forth, somewhere or the other. And structural fire protection is a concept which became very popular when the World Trade Center in 2011 was attacked. And it was because of the huge amounts of fire that the building lost its structural integrity and fell inwards. So these three aspects are important to know as concepts, because these concepts need to be realized properly. And contrary to a lot of people who think we are probably in a smart era where all manufacturing of building materials is almost like a video of a car getting assembled on a shop floor where everything is just mechanized. In reality, this is not how doors are always made. In reality, there is a massive amount of intervention by people who would be involved in doing activities almost manually. And hence, it is important to know and understand the means and methods of quality assurance. And as I said in the beginning, you could get a product into a laboratory and get it tested and say, well, it works. That's not always possible for a lot of products. If a commercial building is getting constructed or a hotel is getting constructed and you have 5,000 doors which are ordered, if you pick up one door and test it and burn it, and one door is gone, what is the means and measure to know that all the other doors will perform. And this is where the concept of certification and listing should be known and very well understood, because these concepts are important to be brought forward when it comes to understanding procurement and supply chains of various materials that are the key construct of any development. I'm not going to read out everything on the screen, but I'm just going to very quickly talk about a concept which is called certification and listing. This as a concept is a means by which different manufacturers, whether it is building materials or electronics and communication and technology products that you see around you, are validated for their verified performance. If you pick up the battery charger that you have around you, you would see a slew of certification marks on it. And these marks are come in because there is a third-party commercial entity who has gone and done all these steps which you see on the screen. But for people who are in the audience, and because we have a very broad spectrum of people who are in the audience, I want to just shed a little more light on how these processes are there. If the Bureau of Indian Standards has come up with a certification program, how that certification program really ensures that the product will perform in its guaranteed or assured properties. And these certification programs, even though they would all do selection and determination of characteristics, etc., it is some very key concepts related to surveillance, which means how do you really go back and check what is coming into the market? What is the feedback mechanism? And this is important to know from a procurement cycle. There are hundreds of examples of failures in cities and countries and construction around the world. And as people of the country who are going to take key decisions in ensuring that certain infrastructure which is created will be saluted 100 years later and 80 years later, it is important to understand supply chains of materials around the world and what are the methods which are existing today in checking how these supply chains really work or do not work. So moving forward, another very important aspect is that when and after you have an assurance that there is compartmentalization which is maintained and fire safety is brought about properly, the cables and the mechanical, electrical, plumbing comes in. 35% of the cost of construction of any building is mechanical, electrical, plumbing, which means all the contractors, suppliers, and material sellers will come and cut open and break the walls just for getting their pipes, their cables, etc. in the place. And that's where all of these compartmentalization need to be fire stopped, contained, and done properly. This is extremely important to know of in smart cities, because at the background of all the buildings are these hundreds and thousands of interconnections, because all the measurement has to go back somewhere at a central repository. So it is important to know what these fire stops are. The National Building Code of India has some definition about it, but within the context of India and within the context of the cities that will be, it is important to know that there is a requirement of inspections, there is requirement of maintenance. If these things are not done properly, once the contractors, the subcontractors, and material suppliers go away, it is the residents and citizens who have to live with all the errors that kind of got created in the construction and it just went away. So hence, it is important to understand the process and the metrics behind inspections that are important. There are standards which have been written, and these standards should be used by people who will be involved in key decisions in the country. And I started off with talking about code compliance. I would like to point out that these are some of the standards that will create a good amount of business opportunity in our country for people to be more Atmanirbhar, as we are talking of. So it is important to know the language of codes and standards and guides, and how these are the backbone of creating an implementation of what is fire safety. So I'm going to take a very quick example towards as I end my talk, so that we have enough time for question answers as well. The building code would define how to design a building, how to design fire compartmentalization. And as an example, if some people are related to the construction industry, they would know that people talk about fire resistance rating, and a compartment or a door or a partition is 1 hour or 2 hours fire rated. But it is important how this mechanism gets rolled out in reality. A subcontractor tenders out saying, well, I want to procure 5,000 doors. How do you really check that these doors are fire resistance rated? And what I explained earlier as well, we were talking about certification and listing, and how there are methods to ensure that there is traceability of building materials, and we do not end up with massive fires that keep happening all around us. Here is a quick video which shows that yes, you could pick up a door and get it tested to validate whether it performs or not. But how do you really ensure that the process is being validated at the manufacturer's premises? So I'm going to talk about a concept which is extremely well used in the world around. The concept of certification and listing, where a buyer can go to the certification directory and look up almost all information related to the conformity of the supply of materials on a certification directory. And this is one of the things that is very important for people to know in India. And if you pick up a phone of yours, and maybe you have a iPhone or a Samsung phone, you would see CE written behind it or under it. But for many products under CE, there will be a 3 or a 4-digit number. And if you look up this 4-digit number or a traceability number, you will be able to find out not only which factory where the product is produced, but you will also be able to find out who is the third-party certification body, like an entity, like a SGS or TUV or Bureau Veritas or Intertek or UL or any of these companies. Who is the company who is going to the factory and validating that each and everything in the plant is being reproduced to provide repeatability of results? So hence, it is important to know that all of this information is available for almost all products which are internationally regulated. So if you look at any electrical appliance, at least outside of India and sometimes even inside India, you would see a traceability number that can give you the assurance and the validation that what is it tested to, what will it conform to. So that's a very, very big overview today. I wanted to talk mainly about conformity assessment, what conformity assessment is, but I also wanted to kind of open several doors for listeners to the world of standards, to the world of standardization, and how these standards get developed. Why do they get developed? What is the process by which these standards are used in the world around for various aspects? So I hope I was able to do justice to today's session. I did not want to go in a lot of detail because topics around smart cities or compliance or fire safety can go into days and days and days. I wanted to open a lot of doors for people to kind of just get exposed to different ideas. And of course, at a later point of time, we can connect, we can interact, and so on and so forth. So that's the end of my quick presentation. I hope this helps bring about some concept, and we can have some question and answers as well if required.
Yes, sir. Thank you very much. Any questions, please, from the participants? Sir will be answering. You can type it in the chat box, or we will unmute you. Or maybe. Okay. Now, actually, we have to unmute yourself. If there are any, I mean, you can.
I'm going to read out one of the questions and try and answer. Manmohan wants to know that how far are we from internationally acceptable standard system ISO? So Manmohan, you will be very happy to know that the way ISO, or the International Standardization Organization, works is that an extremely large number of countries, almost all, are members of ISO. And among the hundreds and thousands of standards, the BIS, the Bureau of Indian Standards, which is a member of ISO, has a say in it. So there are lots of places where you and people like us can go to BIS, say, I want to be a member and I want to contribute to this technical committee and give a feedback about it. So A, we have a say in the development of the standard process. B, the second part to your question, how far are we? Well, there are thousands of standards and codes for different kinds of products and materials. Anything that you see around you, the laptop, the computers, the mobile phones, they all have a standard for validating some or the other performance. For many things, we do not follow any of these standards in India, or they are not minimum requirements for procurement. And hence, nobody will spend any money to comply to these standards. If there is a standard which is minimum, is required, if there is a tender that comes out for, let's say, the next smart city, where someone says that all the Cat5 cables for internet connectivity, or all the electrical cables, or all the phones, or all the modems need to comply to a specific given standard for performance of electrical safety or behavior, then everybody will be complying to it. But otherwise, your question is very open-ended. I would not be able to answer. Good stuff. Anything else? I would love to get a feedback and see if anybody wants to keep in touch. I would be happy to take up questions, or just come back to you later. You have my email address, and anybody who wants to know more and is interested about any of these things will be happy to help. There you go, Manmohan. That's my email address.
Any other questions, please? Okay. If there are no questions, actually, you can forward the question. You can send the question to the email which sir has posted here, Abhishek Chabra sir. So if there are no questions, I thank Abhishek Chabra sir for his wonderful presentation on behalf of Department of Civil Engineering, Nitte Meenakshi of Technology, and he has covered very informative things regarding codes and standards for fire compliance, of fire safety, and how to arrest within the process of certification program and etc., maintaining compartmentalization, and also opening the doors for list of standards, and also the regarding the fire safety hazards. Thank you very much, sir. It's a wonderful presentation.
Thank you very much. It is good to be on this forum. Thanks to, of course, Dr. Bharti and the whole that has created this program. I wish everybody a lot of success, and look forward to supporting any initiatives in the future. Thank you very much. Bye-bye.
And also, we sorry for the delay in the sessions which had happened due to the inauguration session. Thank you, sir.
Understandable. Okay. Thank you. Bye-bye then.
Bye, sir. Thank you.
Participants, like if you have any queries, the email ID is provided. You can forward the queries or contact the speakers through that email ID. And for any more queries, you can contact any of our coordinators. And please feel free to post your queries or mail them. So we're ending today's session. See you tomorrow. Thank you all for your active participation. Thank you.